measurement of voltage and current when two dependent sources present in the circuit. Okay, this is the circuit diagram. Here there are two different types of dependent sources present in the network. The first one is called current dependent voltage source. It depends upon current I2, like this. Current flowing to the R2, that is called 1 kilo ohm resistor in this direction. Current flowing to the R2, that is called 1 amps. IS is equal to 1 amps means current I2 is equal to 1 amps. Okay. This dependent source is depends upon the current flowing to this R2 resistor. And next, current dependent current source, that is called F 0.5 into I naught. So it is depends upon current flowing to the here I naught 6 voltage source. So like this, when two dependent sources are activating simultaneously in the present in the network, then how to calculate the so node voltages V1, V2, and also current flow into the R1 resistor, and also current flow in the voltage source, dependent source. And also what is the value of I naught. Here, let us assume this is called V1, V2, then V1 voltage. What is the V1? What is the V2? What is I naught? What is I2? And what is the current flow into the this dependent voltage source? For example, I3, and also current flow into the 100 ohms. Like this, these are the different types of unknown things we have to find by using PSpice. And first, so by using with the theoretical calculations. Coming to the circuit for solution, this is called circuit diagram. Here we have to find, let us assume this is called V1, V2, and this is called I2. And let us assume the current flow into the dependent source is called I3, and this current 0.5 I naught in this direction. Okay. So according to the question, they given like this. This is the current. This current is called I naught, and this current is called current leaving from this dependent source. Current dependent current source direction is called upwards. This current direction is called downside. So this current direction is downside. This current direction is upside, upward direction, and this current source, independent current source direction downside. So current entering, and this current leaving. Okay. So like this, so you will get one equation here. Understood? Current. So first here, so V1 is equal to 6 volts. This node voltage is called 6 volts. So because of positive voltage source, this independent voltage source, positive polarity is connected here, and the next is called ground. That's why this node voltage is called plus 6 volts. And then next equation here in this loop, uh, applying KVL. So minus 6, na? You are entering minus 6. And here, what is the voltage here? 100 ohm resistor. Across the 100 ohm resistor, what is the voltage? So plus 2I2, this is called voltage source, is connected exactly parallel to the 100 ohms. That's why positive here and negative here. That's why this is called voltage. 2I2 is called voltage present across the 100 ohm resistor. Then voltage is called minus 6 plus 2I2. And then what is the voltage here? Across the 0.5 I naught, that is called current dependent current source. What is the voltage? Is called V2. So minus 6 and plus 2I2 plus V2 is equal to 0. Like this, we will get the equation. And this current I2 is called current flow into the R2 in series with this independent source. That's why I2 is equal to IS, that is called 1 amps. So, okay. Substitute here, then we will get answers. Minus 6 plus 2 into I1 plus V2, then V2 is equal to 4 volts. Like this, we will get answer, V2 answer. And then next here, current I naught entering, okay, 1 amps current entering, and leaving current is called 0.5 into I naught. This is the equation. Fourth one is called I naught current entering, and this 1 amps current entering, and 0.5 I naught leaving. So then here only one known is called I naught. Then by using this equation, so we can get I naught is equal to minus 2 amps. Okay. This direction downside is called minus 2. Actual direction of this current I naught is called upward direction. That is called 2 amps. If it is downside direction, minus 2 amps. Okay. So V2 completed, I naught is completed, and also I2 is completed. V1 is completed. Then next, what is the current flow into the 100 ohm resistor? 100 ohm resistor is nothing but V1, this voltage minus this voltage by resistance. V1 minus V2 divided by 100. So V1 is called 6 and V2 is called 4. 6 minus 4 divided by 100, that is called 2 by 100, that is called 20 milliamps. Okay, this current is called current flow into the 100 ohm resistor is nothing but 20 milliamps. Then what is the current in this direction? I3 current. I3 is called this current entering, okay, or I3 is equal to at this node, at node V1, this current entering, I3 is entering, I0 is leaving, and also this current 20 milliamps also leaving. So I0 is called 2 milliamps minus 2 milliamps. 100 is called current flow into the this resistor is called 20 milliamps. Then 0.02 minus 2. So that is called minus 1.98. This current direction. If it is current direction in this plus 1.98, here minus 1.98 amps. This is the current direction. Okay, like this, these are the theoretical calculations. And then this can be simplified. This can be understand by using PSpice. The solutions are correct or not. Okay, we have to verify by using PSpice schematic. Okay, so open PSpice schematic. Open PSpice schematic. Right here, PSpice schematic. Like this open PSpice schematic. Here, this is the circuit diagram, and take the elements from this PSpice library. Okay. So here, take VDC. Right here, independent source VDC. VDC. Place here VDC, and is required two resistors. Or place two resistors here exactly parallel like this as per circuit diagram. Take one dependent source E is called voltage dependent voltage source. H current dependent voltage source. So this is called current dependent voltage source. Place here. Next F current dependent current source. Place here current dependent current source. Then next IDC. Right here IDC. Place this IDC here. Okay. And this is our circuit diagram. From this circuit diagram, VDC, IDC, and resistors connect first independent sources. VDC to resistor, and this resistor to here, and IDC. The current direction is downside only. Okay. And here this is called connected. What is the direction of the source? Upward direction. Okay. The source direction is called upwards. That's why controller rotate in this way. Place here and connect this source here. And this voltage source, what is the direction of this voltage source? Plus minus, here this side plus and minus. That's why control R. Here plus, left side is plus, right side is negative. That's why place here. It is easy to connect. Here left side is positive, right side is negative. In this way. This is called dependent source connection. Okay. And next is where depends on current I2, current flow into this resistor. And Connect this voltage source properly. Take one ground, place here. Okay. Here, this voltage source is depends upon current flow into the R2 resistor, this resistance. Okay. First change the values of voltage source. What is the voltage here? What is the voltage? 6 voltage, 6 volts here. Change the resistance voltage to 6 volts. And the resistance is called 100 ohms. Here 100 ohms. And this resistance as it is, no changes in resistance, 1 kilo ohm, R2 1 kilo ohm. And the IDC how much? 1 amp. Open this current source and write here DC 1 amp. 1 amp, save alter, then okay. Then now connect dependent sources. This dependent source is depends upon current flow into this R2 resistor. So that's why remove this element and current leaving from this branch and entering into this way. Example like this. And leaving from this voltage source, current source. So this is the connection, dependent source connection. This is the current 2I2 is depends upon current flow into this resistor, R2 resistor. After R2, the current leaving and flow into the dependent source. Current leaving and entering into the dependent source and coming back to the dependence, like this circuit. Then next, this current dependent current source. How it is connected? Current dependent source is where it depends upon 0.5 into I naught. It depends upon current flow into the 6 voltage source. Okay. So let us assume here this is the current. Okay. Current leaving from this source and entering to the dependent source in this way and leaving from this dependent source. Connect in this way. Okay, this is the connection. So like this. It is depends upon current, na? That's why current leaving from the R2 and entering into the R2 same direction and also leaving into the R2 like this. And also this current dependent current source is depends upon current flow into the 6 volts. So that's why current leaving from the this I naught entering into the dependent source 0.5 into I naught and open here, right here, open dependent source and write I naught. Right here 0.5, 0.5, save alter, then okay. What is this 2I2? Na? It depends upon current. This gain is called 2. Save alter, then okay. 6 volts and 100 ohm resistor 1K. So 1 amps leaving in this direction as per circuit diagram. So everything is adjusted. Everything. Okay, then simulate. Simulate and save dependent. Okay. Then after simulation, press V and I. First V. First, what is this voltage? 6 volts. And what is here? Voltage is called 4 volts. This node voltage is called 4 volts. Take V band and place here 4 volts. This voltage is called 4 volts. Okay. Understood. So according to our theoretical calculations, this voltage is called V2 is called 4 volts. The same. Okay. And the next coming to the here 6 volts and the next current. So current here 2 amps. Current flow into the source is called 2 amps. What is the direction of the current here? Upward direction. Upward direction. This current is I naught. Okay. According to our circuit, this current is called I naught. I naught is equal to 6. I naught is equal to here 2 amps. According to our theoretical calculations, I naught is equal to minus 2 amps. So when downside is called minus 2, upwards is called upwards direction is called positive. Okay. So this current upward direction is called positive, 2 amps leaving from the source. Okay, like this. And next this current 1 amps as it is, no changes. And here 2 amps current. This current is called 2 amps. Na? I naught is equal to 2 amps. So this is 0.5 into I naught. That's why here 2 amps shows like this dependence current. Then next coming to the current 20 milliamps. What is this current flow into the 100 ohm resistor? Is called 20 milliamps. Current flow into the 100 ohm resistor is called 20 milliamps. That is called I3, I100 is equal to 20 milliamps like this. This is the calculations. Next, I3 is equal to 1.98 amps. Current flow into the dependent source is called this is called dependent source is nothing but 1.98. What is the direction? In this direction. Okay. If it is in this direction, minus 1 point. If it is in this direction, so current is 1.98 amps. So like this, we can get these results by using P-Spice. Okay. So this is about for dependence. When two dependent sources are present in the network, what is the solution?